This is what a sine wave looks like. AC voltage sine wave on the oscilloscope on the left. And a true RMS meter will measure, for example, 10 volts AC. Now AC means alternating current, and you'll notice that in the middle here, that line right across, that's 0. And so above it is positive, below it is negative. Full wave rectified takes these and flips them over so that you'll see a ripple. This is the same strip using full wave rectified DC without filter caps. So if you look at the monitor, that's what full wave rectified DC is. You'll see that this line right here is the 0 volt line. So instead of having a sine wave, which would normally, you can see where they connect to each other, the waves. Normally it would go into the negative because AC alternates back and forth. So it would be down here, but the rectifier flips it over so that you get a DC. But that's called a ripple up top. Now without any filter caps on it, you can see that it's got a little bit there. Now as far as the LED is concerned, you'll see that as far as the eyeball can tell, you're not going to see that. This is a 60 hertz sine wave that's flipped over and it becomes 120 hertz ripple. So 120 times a second it's doing what you see there. Now I set it up to a average of that meter right there and the amber light. That's averaging 11.912 volts. You'll see that the current draw on this strip is 2.25 to 26 amps. Foot candle is 121. So you'll see that the voltage is, the foot candle levels pretty much stay the same, but the work to get to that foot candle level increases, and that's because when you see a sine wave, or you see a wave like that, the average is at some point in between. And so this 12 volt average is right around right here. Each one of these lines is 5 volts. So you'll see that the ripple goes up to approximately 18 volts. So for a portion of time it's at 18 volts, and for a portion of time it goes down to almost 0. As far as the foot candle levels are concerned, it's getting approximately the same. There are pros and there are cons to driving LEDs this way. Okay, that's with the caps. You'll see that it's about 2 volts of ripple. So what does that mean? It means the difference between the high and the low voltage is 2 volts. So in essence, very minor ripple. I took a 18 volt battery pack. I'll put that on the meter so you'll see how it looks like with a battery, which is the truest form of DC voltage.